A company that started out making budget smartphones and rice cookers, walked into the car industry, looked Porsche dead in the eye, and said, "We can beat you." And then, they actually did it. The Xiaomi SU7 Ultra just ran the Nürburgring in 6 minutes and 46 seconds. That's faster than a Porsche Taycan Turbo GT. A car from a phone company is now one of the fastest production sedans to ever lap one of the most brutal racetracks on Earth. And the speed is honestly not even the most impressive part of this story. What Xiaomi did to get here, the materials they invented, the machines they built, the way they completely rethought what a car actually is, that's the part that has the entire automotive world paying very close attention right now. Here's the thing that most people don't realize about how cars are built. The basic process hasn't changed that much since the 1950s. You take flat sheets of steel, you stamp them into shapes, and you weld them all together. Hundreds of individual parts, thousands of welds, hours of labor per vehicle. It works, but every single weld point is a weak spot. Every extra part adds weight, and weight is the enemy of both speed and efficiency. Tesla tried to fix this with something called Hypercasting. Instead of stamping and welding dozens of separate pieces together, you pour molten aluminum into a giant mold, and you get one huge structural piece straight out of the press. Fewer joints, less weight, faster production. It was a genuinely smart leap forward. But it came with a problem that nobody could fully solve. When you cast aluminum in a mold, the metal comes out structurally weak on the inside. The fix is to bake it in a massive industrial oven at very high temperatures for hours. This lines up the microscopic crystal structure of the metal and makes it strong. The catch is that when you heat a huge complex piece of metal like that, it warps slightly. It bends and twists in tiny but critical ways. And when you're building a car where every millimeter of alignment matters, even a small warp means doors don't close right, geometry is off, and you've got a very expensive problem on your hands. So manufacturers were stuck. Either skip the heat treatment and have a part that keeps its shape, but isn't strong enough. Every major automaker hit this wall. Most of them just quietly accepted it as an unavoidable limitation and moved on. Xiaomi refused to accept it. They built an AI system they called Material Genome and gave it one specific mission: find an alloy formula that is strong, flexible, dimensionally stable, and needs absolutely zero heat treatment after casting. The AI ran simulations of over 10 million different alloy combinations. To put that in perspective, if a human chemist tested one new formula every single day without taking a single day off, it would take over 27,000 years to run through that many combinations. The AI did it in a fraction of the time. What it found was a blend of aluminum, silicon, magnesium, and rare earth elements in a very specific ratio that nobody had ever tried before. Xiaomi called it Titan's metal. It is strong enough for a high-performance chassis. It holds its exact shape after casting with no heat treatment needed at all. And because they're skipping that entire oven baking step, each part comes out of the mold and goes straight into the car. No warping, no hours of waiting, no compromise. But inventing a new metal was only half the challenge. You also need a machine capable of actually using it at the scale of building thousands of cars. Xiaomi built one. They call it the Hypercasting machine, and it is enormous. We're talking about a machine that takes up roughly the floor space of 2 basketball courts. It generates 9,100 tons of clamping force. And it uses that force to inject molten Titan's metal into molds with such precision that the finished piece comes out ready to use with no additional treatment required. Here's how dramatic the difference is in practice. A traditional car rear floor structure is made of 72 separate stamped parts held together by 840 individual welds. Each one of those parts has to be manufactured, transported, stored, picked up, aligned, and welded. The whole process takes hours. Xiaomi's Hypercasting machine produces that exact same structural section as a single piece in 100 seconds. 72 parts become 1. 840 welds become 0. The finished section is 17% lighter than the traditional version and measurably quieter inside the cabin because there are no tiny gaps or imperfect weld points vibrating against each other. And immediately after casting, every single piece gets scanned by X-ray imaging and high-precision laser sensors before it ever leaves the machine. Any flaw at all, and the part is automatically rejected. The quality check is happening at a speed and detail level no human inspector could match. Now, if you think that's the wildest part of this story, wait until you hear what they did with the battery. In almost every electric car on the road today, the battery is essentially a heavy box bolted underneath the floor. It stores energy and it does nothing else. It doesn't help hold the car together. It doesn't add structural rigidity. It just sits there as dead weight that also happens to power the motors. Xiaomi asked a simple question that turned out to be worth everything. What if the battery wasn't a passenger in the car? What if it was actually the skeleton? Their answer is called CTB technology, which stands for cell to body. Instead of a separate battery box attached to the frame, the battery cells are built directly into the structure of the car. The top surface of the battery pack becomes the actual cabin floor. The cells aren't just storing energy, they're actively carrying the structural load of the entire vehicle. And then, Xiaomi added one more decision on top of that. They flipped every battery cell upside down. Here's why that matters. Each battery cell has a pressure relief valve, a small safety feature that lets hot gas escape safely if the cell overheats. In a normal setup, those valves face up toward the passengers, so engineers have to pack thick layers of protective material between the battery and the cabin floor. It's necessary, but it adds height and weight. Flip the cells upside down, and those valves point downward toward the road instead. The safety is handled by the floor of the car itself. You can remove all those thick internal protective layers. The result is a battery and floor system that is only 120 millimeters thick total, roughly as thick as a hardcover book. The car sits lower, the center of gravity drops, and because the cells themselves are part of the structural load path, the entire chassis becomes extraordinarily rigid. The SU7 Ultra measures 51,000 Newton-meters per degree of torsional stiffness. A Ford Raptor, one of the toughest trucks on the market, sits around 25,000. The Xiaomi sedan is twice as stiff as a trophy truck and stiffer than a Bugatti Chiron. That rigidity is what makes everything else work. When the chassis doesn't flex, the suspension does its job perfectly every time. The tires stay flat against the road through hard cornering. The whole car behaves exactly as the engineers intended. And what they intended was a car with 1,548 horsepower from 3 motors that each spin at 27,200 revolutions per minute. That's a world record for a production electric motor, spinning 35% faster than most high-performance electric motors. Jet turbine territory in a road car. None of this would hold together in a conventional chassis. But because the metal, the manufacturing process, the structure, and the battery were all designed together as a single connected system, every piece reinforces every other piece perfectly. That's what makes the Nürburgring lap time more than just a number on a board. It's proof that starting completely from scratch, with no assumptions about how things have always been done, is sometimes the most powerful engineering move available. Xiaomi didn't tweak an existing formula. They used AI to invent a new metal. They built a machine that has never existed before. They turned the battery into the bones of the car. And 3 years after the room laughed at the idea of a phone company building something that could challenge Porsche, nobody is laughing anymore. That's what happens when you refuse to accept the limitations everyone else stopped questioning. If this kind of engineering story is your thing, hit subscribe and turn on notifications because we've got a lot more of this coming.